Good morning, one and all present here. I, Dr. Kumari Sarita Prashad from the Department of Chemistry, RN College, Pandal, Madhubani. Today, I am going to talk about MOOCs as a tool for learning solid-state kinetic of metal complexes. This presentation combines two important ideas, modern digital learning and chemistry research. We will see how MOOCs or massive open online courses make difficult topics like thermogrammetric analysis, TGA, and solid state kinetics much easier to understand. By the end of this presentation, you will see how online learning can support both classroom education and research. Let us begin. First, let us understand what MOOCs are. MOOCs stand for Massive Open Online Course. These are online courses that are open to learners from all over the world. Anyone with an internet connection can join without the need for special admission. One of the biggest advantages of MOOCs is flexibility. Student can learn anytime and anywhere, pause the lectures, replay difficult topics, and study at their own speed. Most MOOCs provide video lectures, study materials, quizzes, assignments, and in many cases, a digital certificate after successful completion. Because of these features, MOOCs have made quality education more accessible and affordable for students everywhere. Now let us see why digital learning is especially useful for chemistry. Some topics such as solid-state kinetics and thermal analysis are difficult to understand from textbook alone. Digital learning allows a student to watch animation, graphs, and demonstration that explain each concept step by step. If a topic seems difficult, student can simply replay the lesson until they understand it clearly. Learning at one's own pace reduces the fear of complex topics and builds confidence before moving on to advanced research work. This slide shows how MOOCs support the learning of solid-state kinetic of metal complexes. These online lessons explain a thermal reaction step by step, making complex concept easier to understand. An important technique discussed in these courses is thermogrammetric analysis or TGA. TGA shows how the weight of metal complex changes as it is heated. Through videos and interactive explanations, students learn how to read TGA curves and understand the thermal behavior of different compounds. They also learn that thermal decomposition does not occur all at once. Instead, it takes place in different stages, and each stage provides valuable information about the reaction mechanism and kinetic parameters. Thus, MOOCs make research concept easier to visualize and understand. Now let me explain TGA in simple words. Thermogrammetric analysis is a technique that measures the change in weight of a sample as it is heated under controlled condition. As the temperature increases, the sample may lose water molecule, gases molecule, or other components, causing its weight to decrease. This information is displayed as a stepwise weight loss curve. From this graph, we can determine the thermal stability of the compounds, identify different stages of decomposition, and calculate the amount of residue left after heating. This information forms the basis for studying the kinetics of thermal decomposition. Once we obtain the TGA data, we can use different kinetics method to analyze it. One of the most widely used method is the Freeman-Carroll method. This method applies mathematical calculations to the TGA data to determine two important kinetics parameters. The first is activation energy represented by EA. It is minimum amount of energy required to start the decomposition reaction. Generally, a higher activation energy indicates greater thermal stability of the metal complex. The second parameter is the reaction order represented by a small n. It describes how the rate of decomposition depends on the amount of sample remaining. The procedure is so simple. First, collect the TGA data. Next, prepare the Freeman-Carroll plot. Then, calculate the slope and intercept. Finally, determine the kinetic parameter. As shown on the slide, MOOCs explain each of these steps with examples, making even a mathematical method easier to understand. So, how do MOOCs actually help students? The learning process begin to video lectures, notes, and quizzes, which simplify difficult topics into small, easy to understand lessons. Once the concept become clear, students find it much easier to interpret TGA graph, identify decomposition stages, and apply method like Freeman-Carroll. Since student can revisit the lessons whenever needed, they gradually develop confidence in analyzing research data. As a result, they are better prepared to discuss result, write research paper, and deliver presentation with confidence. Today, many MOOCs platforms provide high quality courses in science and research. Some popular examples include SWAM, NPTEL, Coursera, and edX. These platforms offer courses in chemistry, material science, thermal analysis, research methodology, and many other subjects. Students can choose courses according to their own interest, and learn from expert while studying at their own convenience. Now, to conclude this, MOOCs are becoming an effective tool for learning solid state kinetic of metal complexes. They make difficult research concept easier through video lectures, study material, quizzes, and flexible learning. At the same time, technique like thermogrametric analysis and the Freeman-Carroll method help us understand the thermal decomposition behavior and kinetic parameters of metal complexes. In simple words, MOOCs better learning, better research, understanding. I hope this presentation has shown how online learning can successfully support traditional classroom teaching as well as chemistry research. Thank you very much. Thank you for your kind attention. Thank you all.